to our channel. Myself Ruchi, and today we are going to discuss Coulomb's law. So Coulomb's law is used to describe about the interaction between the two charges, especially the point charges. For example, if we consider 2 point charges Q1 and Q2 with separation r, then according to Coulomb's law, F is directly proportional to the product of the 2 point charges and inversely proportional to the square of the separation between them. By combining this, we are left with F is proportional to Q1 Q2 by r square. So we can write F is equal to K Q1 Q2 by r square, where K is known as Coulomb's constant and it depends upon the nature of the medium. Here we can see that two forces are acting due to charge Q1 and Q2. F12 is the charge on Q1 due to Q2 and F21 is the charge on Q2 due to Q1. Here we can take two vectors, that is R21 and R12. R21 is in the direction of the force F21 and R12 is in the direction of F12. From the figure we can see that R is equal to the mod of vector R12 and the magnitude of the vector R21. So in vector form, we can write Coulomb's law like F12 is equal to K Q1 Q2 by R. Basically, we use a unit vector to define or describe the direction of the force. So here we will use unit vector R12 in the direction of F12. We had already studied in class 11 that unit vector can be written as the vector divided by the magnitude of its vector. So here also we can write R12 unit vector in the form of the vector R12 divided by its magnitude. So here we are also saying that radius is equal to the magnitude of the vector R21 and the magnitude of R12. Hence the R12 is in the direction of F12. So we can conclude that this R12 can be written in the form of R. So here we are left with F12 is equal to K Q1 Q2 by R cube into R12 vector. We can calculate F21 like we can write F21 is equal to K Q1 Q2 by R cube into R21 vector. Here we can see that R21 vector is in the direction of the force F21. So from both these equations we can conclude that the magnitude of the force F12 and F21 is equal, but they are opposite in direction because R21 and R12 are opposite to each other. Hence we can say that both these forces forms action-reaction pair and hence they follow the Newton's third law. One more important point I want to say, that is the force always act along the line joining both the charges. To discuss the permittivity and relative permittivity, which is an important part of Coulomb's law. So as we are seeing in this equation that here is a K which depends upon the medium. We can also write K as 1 by 4 pi epsilon, where epsilon is known as permittivity. And permittivity is a property of any medium. So what is permittivity? So property of a medium which permit its own field to decrease the interaction between the charges. Means it allows its own field to decrease the interaction between the two charges. From here also it is clear that F is equal to 1 by 4 pi epsilon Q1 Q2 by R square. So here is the inverse relation between the epsilon and force. When we will increase the value of epsilon, then force will automatically decrease. Basically, we denote permittivity in air by epsilon naught and the force in air by F naught. We should keep in mind that the value of epsilon naught is always minimum as there are no particles in the air which will decrease the interaction between the two charges. Hence, we can also say that force is maximum in air and the value of minimum permittivity is equal to 8.854 into 10 to the power minus 12 coulomb square per Newton meter square. This will help us in calculating the force in the medium which is air. So we can also write that the permittivity of any medium is always greater than the permittivity in air, and we can also write that the force in air is always greater than force in any medium as there are no particles present in the air to decrease is the interaction between the fluid. Now we will discuss about the relative permittivity. Can be defined as the ratio of the permittivity of the medium divided by the permittivity in air. So we can write that epsilon r is equal to epsilon m by epsilon r, where epsilon m is equal to permittivity of medium and epsilon r is equal to relative permittivity. We can also denote the relative permittivity by kappa, which is known as dielectric constant. Suppose in the question it is given that the value of ER of water is equal to 81, then we have to calculate the EM, that is the permittivity of water. Then we can calculate by using this formula. So we can write here that the permittivity of water is equal to relative permittivity into epsilon r. So here in the question it is given that epsilon r is equal to 81 into epsilon r, where epsilon naught is equal to 8.854 into 10 to the power minus 12 coulomb square per meter square. Hence in this way we can easily calculate the permittivity of any medium by only